Okay, so now we want to look at some examples with paired samples. The criteria are exactly the same, except for now we're looking for something in the wording that lets us know that these are paired or that the samples depend on each other in some way. Okay, so the first one we're going to look at is a confidence interval example. So we have researchers examining 40 subjects who were randomly assigned to the Weight Watchers diet. These subjects were measured twice, at the start of the study and 2 months later. And I'm going to just stop right there. I've got all kinds of information already. I already know that we're good to go sample size wise because that is bigger than 25. This says the subjects were measured twice. So this is like a before and after situation. So right there is why we need to use the paired test. It was the same subjects measured twice. So that's a key before and after type thing that lets us know this is paired. It says then the data consisted of two variables, their weight at 0 months and then their weight at 2 months. One question we can ask is how much weight will the typical person lose on a Weight Watchers diet after 2 months? So we actually have checked off that this is going to work, it's going to hit the criteria. We know why we need to use a paired test. I'm not going to run the paired test. We're actually just looking at what the StatCrunch would spit out when you run that on this one. So in this case, sample 1 was the 2 months and sample 2 was the 0 months. So we want to explain the 90% confidence interval that they created. So one thing I want to note to you is this mu sub d. That's that difference score that we talked about in the very first video of this section. And that's how you also know, like once you're on the page, that's how you know that you're in the paired area. Anything that has to do with paired means is going to say mu d on it. Notice it's still calculating mu1 minus mu2. So that's happening in independent or dependent. This one is just labeled differently. It's actually labeled as a different score. So we have the confidence interval, the 90% interval from negative 4.49, let's say, to negative 2.44. So that's our confidence interval. And as a reminder, they were doing 2 months and then 0 months. So they were taking the mean weight at 2 months and subtracting the mean weight at 0 months. And these are the numbers that they got back. So I'm going to write my sentence then. Something like, I am 90% in this case, confident that the difference in mean weight between month 2 and month 0 is between negative 4.49 pounds and negative 2.44 pounds. It's like, okay, that's helpful, but I think that that's still maybe somewhat vague. If you were explaining this to someone who's not in a statistics class with you right now, they maybe don't still understand what you're trying to say. So I would follow that up with, because all of these numbers are negative. So because all the values in the interval are negative, what do we know? Well, we were doing month 2 minus month 0, and we were getting negative numbers. So if we were to move this over here, that statement we would then be making is that the mean of 2 months is less than the mean at 0 months. Now I finally think we've got this written and structured in a way that would make sense to your average person. So because all these values are negative, what we are knowing is that on average, weight loss is happening. Or on average, weight at 2 months is lower than weight at 0 months.